Alright, so now moving on to case number 4. In this case, the focal length is given, height of the object, place 12 centimeters from the lens, but the scale says that 1 centimeter represents 2 centimeter. So if this is like a 1 centimeter box, it's actually 2 centimeters. So again, I'll start with the first thing, which is labeling F and 2F points, because it's now 2 centimeters representing each small box. So I'll just go 4 boxes in either direction. So 1, 2, 3, 4. This is F. 1, 2, 3, 4. This is 2F. And then similarly 1, 2, 3, 4. F. And 1, 2, 3, 4. 2F. Alright. Now the object of height 7 centimeters placed 12 centimeters from the lens. So 12 centimeters means that it's going to be right in the middle of here, right? Because 12 centimeter means 6 boxes. So it's going to be here, and the height is 7 centimeters. So 7 centimeters means 3.5 boxes. Let's try to make that. So 1, 2, 3 and a half. All right, so that's what this looks like. Yeah. So now we mark this as our object, and we now need to make the image. All right, so from the object, again, let's draw the rays. So this ray, and then the other ray, and then passing through F. So for this one, you might need to make like really long lines to see how this image is formed. So again, how we see the image being formed now is that the image forms somewhere here. All right. So this is our image. Yeah, more or less it's somewhere here. Let's mark this as our image. Okay, let's try to make this a bit better. All right, so making sure that they pass through those points accurately, this is where the image would be seen to be formed. All right, so where is the image forming now? So with the object between F and 2F, the image forms beyond 2F. Again, properties. So again, this is real, still, inverted, still. And it's also, if I now talk about the magnification, so the image is much larger, I would say this is magnified, because obviously the image height is greater than the object height. Generally, I would say that this is greater than 1. What if the examiner asks me to actually calculate this? I can do this very easily. So image height over object height. Now I could either use the actual height or I could use the number of boxes. I just feel like going with the number of boxes here because that's something I can immediately see. So image height, if you see here, so 1, 2, 3, 4, 5, 6, 7, that's 7 boxes divided by, here this was 3.5 boxes. So the magnification turns out to be 2, which is greater than 1. So this is all fine here. You could have also done the same thing with actual lengths in centimeters. Here it would be 7. Here this is 7 boxes, so 7 times 2 would be 14. 14 over 7 would also give us is 2. Right? Again, magnification does not have a unit. It's just how much the image has grown by. Right? So it's just a ratio. So applications of this. So this case is used in projectors. So in projectors, where the image formed is larger, Why is the image formed by the projector not inverted? Because there is another lens which inverts it back again to give us an upright image and photograph enlargers. Alright, the detail of how these work is not really part of your syllabus. Case 5. Object at F. So the object at F, focal length is given. The scale is very straightforward, again drawn to scale. So again we'll just need to mark those. So 1 2 3 4. So 1 2 3 4 F, 1 2 3 4 2F. Then on the other side 1 2 3 4 F, 1 2 3 4. This is 2F. So an object of height 6 centimeters is placed at F. So 6 centimeters. So 1 2 3 4 5 6. And now I need to make the rays. So when I make the rays, what I'll see is this, that when I take this here, this is how this ray looks like, and then making this. So now if I make the other ray here with this ray, this is how these are gonna go. So if you see here, in this case, the rays do not appear to be meeting, right? So they are parallel, so they do not meet. In such a case, it's my responsibility to check if it's not intersecting here. So if it's not a real image, maybe it may intersect back here. Maybe it's a parallel, it's a virtual image. So, but the idea is that even if I take these rays back here, like this, because they were parallel in front of the lens, they'd also be parallel behind, so they won't intersect. So there is no image formed in this case. As such, there are no properties or applications either. All right. Case 6. Object between O and F. Focal length is given as 36 centimeters. Object of height 8 centimeters is placed 16 centimeters from the lens. Scale 1 cm represents 4 cm, right? So if I need to mark 36, so according to 4, this means what, 9 boxes, right? So let's mark these. So 1 2 3 4 5 6 7 8 9. Again, I can't really mark 2F, and that's fine. 1 2 3 4 5 6 7 8 9. So this is F. Let's try to center this a bit. With this done, object of height 8 centimeters, place 16 centimeters from the lens. So 16 centimeters means 4 boxes. So it's somewhere here. So 1 2 3 4, right? 1 2 3 4, and the height is 8 centimeters, so it's only 2 boxes high. And now I need to complete this drawing, right? So with this, I'll start making ray 1, which is like this. All right, so that's ray 1, and then ray 2, which is like this and appears to goes through F. Again, in this case, if you really see here, so in this case as well, they do not meet in front here. But the cool thing about this is that if there's an observer here, so let's make the observer again. This is probably too big of a pupil. So with the observer here, he would actually be able to see an image. And how is this image formed? That's if you take these rays back behind the mirror as broken lines. All right, let's get a couple of broken lines here, because here these rays are actually not coming from here, but they just appear to come from behind. All right, let's make this. This might be difficult. Again, these ideally should be broken lines. It's going to be difficult for me to make them because of the software and how the draw tool works here. But you should make it like this when drawing. All right. So with these rays which are taken back as broken lines, and let's try to do this as best as we can. So we see that the rays appear to meet together at this point. This is the formation of the image. All right, so in this case, this was the object, this is the image. Now this, when we try to write down the properties, is that this is a virtual image because the rays are actually coming from the object, but to this observer, it would appear as if it's coming from the image. All right, so this is a virtual image. It cannot be captured on a screen. All the other cases, except for the one before this where there was no image formation, all of those have real images. This is the only one which has a virtual image. Other than this is also the only case yet where we have an upright image, because here the arrowhead is on top, here the arrowhead is also on top. Third, with regards to magnification, this is an enlarged image, and now we know how we can find the linear magnification value as well. For example, in this case, this is like 10 boxes. This is probably like, what do you call it? Maybe like, so if this is like 2 large boxes, this is like almost 3.5. So we can find the linear magnification accordingly. Another important property according to which I'll write the image formed here is that this is the only case where the image is formed on the same side as the object. So this is the image formed on same side as object. And the application for this is in a magnifying glass. So if you really think about it, when we're looking through a magnifying glass, we're looking as the same, we're looking through, as opposed to where the object is, we're looking from the other side where we see an image being formed, right? So this is all of these lens cases. Again, if I were to just go through all of these again, so for the first case, this is how it was, and again we are gradually bringing the object closer together. So infinity, it forms at f, then at 2f it forms here, somewhere between f and 2f. Then I bring it closer, the image also, basically the image gets further out here, and then I bring it further, the image goes out further. At f there's no image formation, and then the sixth case with the image, the object between o and f, the image is formed on the same side as the object. All right, so here we're not saying whether it's formed before f or not, because it actually depends on where the object is placed. But generally, we can talk about it like this. So these are all the lens cases. This is the crux of the chapter. Now only a few minor concepts are left, such as the defects of vision, which will be covered in the next class, in the next video. So see you there.